This is a demonstration video, and probably on its own it's not going to make much sense to you unless you have seen the poster or came to the GitHub repository, but hey, here it is. I just decided to put it on YouTube and completely public, single take, not very professional, so to speak, but I'm at the conference venue right now recording this in an empty room, so at this point, fine, anything will do. So, this is for my poster, and we are doing a lot of like pulse width modulation dimming, which theoretically should be a completely linear process. Okay, so you can imagine that you have like this really fast switching square wave, and you can emulate this slow, beautiful half sine wave in here. And these LEDs are effectively using the same type of drive inside them, but not on the outside. Now, to replicate this anomaly that I reported in the poster, we are going to do a little dirty trick. And before I go into that, I probably should show you what is the schematic. Again, the printer was a little bit tired on the ink, so I had to redraw it. Effectively, we are using a flipper zero here, and we are using the open header. This part in here is 5 volts, which is this line here. There's a 4.7 kilo ohm resistor, this one, and I'm using a green LED as a level shifter, which is then connected to this transistor here. This is what I'm using for my PWM dimming. This LED here is using the 3.3 volt power supply that's coming in from this line here. So it's always getting a nice proper fed power. This LED here is being switched from this transistor, this BC558, and the idea is that I will be able to dim its own power supply through this line here programmatically from the application. So when you launch the application, you will get like a not super great user interface, but the idea is that you get two, and believe me if I say, but this is allegedly white color displays. There are 4 bytes in here. The first byte we are not going to talk about now, but these 3 bytes in here are the red, green, blue RGB values. So if I basically go on and just kill them all gently, like so, you can see the color changing. So this is now cyan. You cannot really see that on the camera because it washes out. This is getting very much bluish, which does come across. And this in here is now super blue, and then you can just dim it down, and then effectively I killed everything now. Okay. Please ignore this. This is just for the level shifting. This just shows that everything is working full power, so both LEDs are absolutely fully powered. Now watch what happens when I go back to the first byte here, and I go alternative input, and I start dimming the power supply of this LED. Now remember, when we looked at this here, it clearly shows that the dimming should be linear with the duty cycle alone, as I'm effectively gently dimming it down. So what we are expecting to see is this LED staying on full brightness, and the second one here, camera doesn't really want to focus, and the second one here will just start dimming down, perfectly linear. So theoretically, there should be nothing of interest to see here. So now I'm starting dimming it down, just basically going down here, okay? And just to show you what happens on the paper, I get a white paper here, like so, and let's try it, see if it works. Yeah, so you can already see it dimming down. It still washes out on the camera, but you can see that this is full brightness, and this is definitely not full anymore, okay? We keep going, okay? It dims down as it expected. And now you cannot really see it directly, but, and believe me when I say it, this LED to my eyes are like distinctly yellow, whereas this one is still fully white. And if I keep going down in dimming, now you can probably see it on the camera that there's a notable color difference between the two. And as I go down, now this is completely and distinctly red. And bear in mind, these two are still receiving the same display data, but we simulated a sort of a degradation process in here. So what is happening is that if you are just dimming an LED, and they are of different compositions, the characteristics of the red and the blue are going to be completely different. And not only that, but the characteristics of the blue LED tend to degrade faster than the red. So this curve and the steepness of this curve is going to shift to higher voltages and is going to have a smaller slope. And this means you cannot pretend that you will be able to drive them together and stay in balance. And also, you cannot pretend to try fitting a power function to this exponential curve. And that's pretty much it.